Welcome to the lightning talk session number 2. So are you excited? Great, so I am more excited. So as always, so we have one important rule. So I asked all the speakers to insert one talking point that will get a storm of applause. So when you find that point, so please give the speaker a big round of applause. Is that okay? So let's practice again. So it's really important to improve documentation of the code base. So I am encouraging everyone to write readme.md to all directories and class level comments. So it's really important. However, you sometimes make a typo. And I found one interesting thing. There are 1,478 in the code base. So please be careful. All right, so I want to call the first speaker to the stage, Eric.
Cool. I want to tell you a little bit about some upcoming changes we're making to the way tracing works in Chrome. What's a trace? It's really a timeline view of the execution in Chrome, including all processes and threads, utilizing explicit trace event instrumentation in Chrome. We use these traces to debug performance issues and to calculate benchmark metrics. So what are we changing? First, we are overhauling the tracing service architecture. We've introduced a new tracing service called Perfetto that's based on shared memory buffers between the instrumented processes and the tracing service. With this new architecture, we can retain tracing data from crashed processes because the shared memory buffer survives the crashes. Because Perfetto is also part of the Android system on P and above, we can also run Perfetto as part of the system and then collect trace data from both Chrome as well as the system, like kernel scheduling details, into the same trace, giving us better holistic view of what's happening on the device. With Perfetto, we're also going to introduce a new strongly typed trace data format, which is based on protocol buffers rather than JSON, enabling longer and more efficient tracing. And with this new trace data format, we will also update the way that you can write trace events in Chrome. We are introducing a new type of trace event macro that uses a lambda to set strongly typed protocol buffer fields on the trace event. But we're not only changing the instrumentation, we're also going to update the tooling. We're going to replace the existing trace viewer at Chrome Tracing with Perfetto's UI. This new UI is based on a high-performance trace processor that's cross-compiled into WebAssembly. It features support for SQL queries on top of the trace model and scale to multiple gigabyte-sized traces. And it's already available for you to try out at ui.perfetto.dev in an early version. Finally, we're also going to add a new way in which you can write metrics based on top of traces, TBMv3. This is also based on SQL queries, uses the same trace processor as the UI under the hood, which also makes these metrics faster and more scalable. And it also means that you can develop these metrics in the Perfetto UI and iterate on them there interactively. So new instrumentation, new trace viewer, and new way of writing metrics. Come talk to us if you want to find out more, or join us in the next breakout session to talk a little bit more about the trace viewer.
Thank you very much. So the next speaker is Miyoung.
Hi, I'm Miyoung Shin. I work for Igalia. I'd like to introduce the pre-site with integer types and WT containers. I work the open Sogo in Blink. Why should you use the pre-site with integer types? The reason that the C++ standards don't specify the space size of each integer types, and the size of integer types in C++ can vary based on the compiler and architecture. Chromium supports the various platforms with one repository and shows the different size of variable with the input size with integer types among billboards for real driver. Imprecise with integer type were changed to precise with integer types we expected in Blink, but apparently they used to be changed on expected types like that. So it's not as simple as some machine-learning works. Sometimes it was required to understand the whole code flow even out of Blink. Finally, we replaced all types in Blink in the second quarter. Yay. Why should you use the WTF containers? The reason that WTF's mission is to power and support all other Blink code base by providing fast, reliable, user-friendly, and secure general primitive. And also, we can use WTF containers with garbage collect called the Oilpan. So, STD containers were changed to WTF containers in Blink. So we replaced all STD containers with the WTF equivalence in Blink in the third quarter. Yay. Basically, we don't allow to use the imprecise with the integer types and STD containers listed at the previous page. So we added a pre-submit check to make sure not to introduce additional them. But there is an exception here. It's allowed only for the boundary layer needing to use them between Blink and Chromie. So there is two options for exception. One is to use the bypass hook when you upload the patch to get it. And another thing is to add the exception rule in your patch. Thank you.
Thank you very much. The next speaker is Julie.
Hello, I'm Julie from Igalia. I'm here to talk about conversion to new Mojo types. Here's some background. Ken Rocker introduced new Mojo type after considering more intuitive name for Mojo types. After that, Igalia team started to work on conversion to new Mojo types. We are sharing the progress with platform dev mailing list. I'll share a bit later. I brought this image from Mojo folder README file. There are two endpoints, logger PTR and logger request connected to message pipe. Like this, previously we used interface PTR, interface request, and the rest of Mojo types on the right side. With new Mojo type, interface PTR is replaced with remote, interface request is replaced with pending receiver. You can find more new Mojo types on the right side. New Mojo types don't change any behavior, and it's easy to read the code with it. If you are already familiar with Mojo types, it's easy to use new Mojo types as well, because these types are mapped one by one. Here's something we should remember, because we used to use interface PTR in many places, such as variables, function parameters, and return types, and class members. But with new Mojo types, generally it's encouraged to use passing pending remote instead of remote because it's more efficient. And new Mojo types are checking status with recheck, which old Mojo types don't have. So sometimes we need to call reset explicitly before binding. Even though the code you are working on has not been fully converted to new Mojo types, please don't worry, because new Mojo types support compatibility. Like pending remote could take interface PTR info, pending receiver could interface request. Here is part of our bi-weekly report. You can find the progress from the slide. And as you can see, we already converted many of them, and only 15% of it are remaining. Yay! We think it's important to complete this task quickly because if two kinds of type exist at the same time, it could cause confusion to developers. So hopefully we could clean up all Mojo types soon. Thank you.
Thank you very much. So the next speaker is Yang.
Hi, I'm Young. I work on DevTools, and I'm going to talk about DevTools. So for those who are not familiar with DevTools, this is the code that we have in DevTools frontend. And you might see that this is not C++, but rather JavaScript and CSS. So this is fundamentally different than most of Chromium, of course. And so DevTools frontend is written in using web technology. It's essentially a web app with some superpowers, a very small set of superpowers. For example, the ability to communicate with the backend via Chrome DevTools protocol. So the architecture looks like this. We have Chromium, Blink, and V8 nested in each other. All of them offer endpoints through from DevTools protocol, and the front end talks to the protocol to enable things that we have in DevTools. Well, DevTools is actually not the only user of that protocol. So it's actually one among other front ends. So we have DevTools front end, we have Lighthouse and Puppeteer and many others actually. So we're thinking, well, why don't we build DevTools as a web app using best practices to build web apps and clearly decouple it from the backend like we have it for other front ends. So that's what we did. We moved it out of Chromium main repo. We pull it in via gclient and the deps file into a directory that's no longer nested inside of Blink. And we have an autoroller, and it's modeled similar to all other dependencies that Chromium has. And we also have our own waterfall where we run tests. And if you want to develop on DevTools frontend, you can just check it out separately, build it separately, and you don't actually need to build Chromium anymore to run your custom version of DevTools. So a couple numbers, checking out the source dependencies and building it actually only takes 2 minutes. This doesn't actually rely on GOMA because we don't compile C++. And we moved around 8 megabytes of code out of Chromium, and a try job completes within 20 minutes. And we have plans to improve it further. All right.
Thank you very much. Next speaker is Alexander.
Hi, I'm Alex, and I will tell you what's Ozone, why it's important for mankind, and what was the progress that my team has done this year. All right, so what's Ozone? It's the layer that abstracts the UI and its numerous objects like browser windows, cursors, UI events, keyboard input, and so on. And for those of you who have some idea what the UI looks inside, Ozone is below Aura. We have started working on it a few years ago when the client requested support for Wayland Compositor, which in terms of Ozone means adding the so-called platform implementation for Wayland. Some of you would ask here, maybe, so what? Wayland? But that's Linux, right? Who needs that? And it's not a joke because I've heard questions like this from many people, including Chromium developers, because Linux is quite minor on desktops, and while Android is massive, it's not really Linux in terms of UI. It uses a different stack. So a better question here would be, which Linux? And the answer is the embedded one. Guess how large it is? That large, 500 million devices. It's smart TVs, home appliances, interactive kiosks and screens, cars, and many, many more. And most of those devices are not capable of running X11, which is the de facto standard for a workstation Linux. But Wayland is much faster. It's like 10 or 15 times faster than X11. That's why it's perfect for low-end devices. And desktops will benefit too, because many major Linux distributions nowadays migrate to Wayland. So what's done? Today, the Wayland port is quite functional. It's OK for daily tasks like browsing the web. Sometimes it may crash, but it's OK. And we use it just for working. The X11 backend is on its way. It has more issues to fix. And also, we have set up the CI configuration. So we have bots which run tests with Ozone enabled. And now, finally, it looks like we will ship it soon, maybe in half a year or so. if you are a Linux user, you can try it at home. I mean, Ozone. So you can see some additional GNRs to build it. Everything is in the Chromium repository. And when you build it, you need a single additional command line argument to enable the backend for X11 or Wayland. That's it. Thank you.
Thank you very much. The next speaker is Peter.
Hi, I'm Peter. I work on DevTools in Munich. I want to talk to you about this problem that a lot of developers have had on the web and that I've had as well, even before I was a web developer. Have you ever done this? You go to declare a class or a let variable in the DevTools console, and it returns undefined, and OK, that's fine. And then you think, actually, I want to change something about that. I want to copy paste my snippet again. I want to put the same thing in there. So you change something about your class, and you're like, yeah, this is great. Syntax error, thingy's already been defined. But you're in this environment where you want to prototype things, you want to get things done quickly. You might not necessarily want, this 100% strict spec enforcement thing that's going on here. So could we fix this? And this has been a question that's been asked for a long time. Yeah, we totally can, and we did. So if you go and have a look on Chrome Canary today, you can see that you can redeclare class and let inside the DevTools console, and it won't throw. It just acts as if you assign to that thing again. I just want to point out that this looks really easy. You're like, yeah, just don't throw that error. That's like one line, right? This was a 700-line CL, which is about half tests. We did 3 different implementations of this while we were prototyping it. In the end, we wrote 17 pages of design docs for this, just to decide on the semantics and the implementation. And there were 7 engineers involved with this throughout the whole process. So it's harder than it looks. That's my point. So yeah, try it out. You can redeclare let in class in the DevTools console now on Canary. We're looking into doing const. It's a bit more difficult. And I just want to point out as well that, yeah, we're messing with the semantics a bit. But if you do let x in one evaluation, that will still throw. So we're trying not to hide errors from developers too much. That's it. Thanks.
Thank you very much. The next speaker is Jason.
Hello, I'm Jason McConnell with Microsoft, and I'm here today to talk about how we can bring web apps and identity and packaging to Windows 10's next version to help integrate the web and PWAs into Windows more tightly. So the video that you're seeing here, we're going to start the regular Edge and Chromium version of the browser. This is Win32. And we install the test application, and you can see that it tears out the tab. We go down to the start menu. You can see that you can find PWA test in the start menu. If you right click on it though, you can see that there's no app settings there. There is an uninstall, which we've kind of hacked up to bring you to the Windows 7 era add remove programs. So then you have to dig through and find that program to uninstall it. It's not really integrated into the modern Windows. Now we're starting an under development version of Edge that has been installed as a content host application. Now when we install this application, the PWA target, Edge is actually creating dynamic packaging on the fly and installing that and registering it with Windows as a child application of the actual browser. So it still appears in the shell as you would expect, but now when you right click on the application, you can see there's app settings because, hey, we have identity now, and you can actually click on that and go into the modern Windows 10 settings for applications and see some of the properties there. This also allows us to participate with the notifications system as well as grouping notifications. And because our test app registered as a shared target, it's also available to be shared information to from, say, OneNote, which is what we just shared this information from. Pretty cool, huh? So let's have a look under the covers and see what's really going on here. So there's the browser as a host, a content host, which is able to stamp out dynamic child processes. If you query the app package model inside of Windows, this is probably too hard for you to see, but this is the packaging that was created at install time for the browser itself. Notice it gets a package name, and it's now available to create its own child processes, sorry, its own child applications. If you look at the packaging for the PWA test application, you can see it's been given a dynamic name. It's got a hash at the end of the value. And the all-important field is just there. It says dependencies, and it's pointing back to the browser's package as its dependency. We're doing this on disk by using a method called side-by-side registration. So the app manifest is right here for the browser itself. It's got the logo. And it's also got the file that we use to sign Edge with. If you go to the PWA test application that we just showed you running, this was dynamically created by the browser, and it puts down 2 manifest files right there on the disk, which is all we need now to have a look at this file and know that it's an application that relies on the Edge content host browser. So now if we go and uninstall this, it's a nice, really nice, modern uninstall experience. It just gives you the simple prompt, cleans up the registry, uninstalls the program, and away you go. So we believe in the web and the power of PWAs, and we wanted to let you know that we'll be contributing as much as we can at this upstream to you guys.
Thank you very much. The next speaker is Abhijeet.
Hello everyone, myself Abhijeet. I am a software developer at Igalia, and today I am going to present about the Bing downcast helpers. The goal of this task was to replace the micro-based implementation with the type-trace-based implementation, which is more type-safe. So what was the motivation? The old implementation was using the micro, and the micros are not type safe. It is difficult to debug and trace the micro-based code, and micro caused to the code blot. Then what's new? In new implementation, we are using the type traits. Type traits are more type safe and secure. It's easy to debug the code, and using the type trait means adoption to the new downcast helpers, new C++ standards. So what was the old implementation? As you can see in the pseudocode, we are defining the micro, and in this micro, there are 3 functions, and each of these 3 functions has 6 different overloads, and in total, there are 18 functions that get defined by the micro, and that's really bad actually. And we have this type of micros all over the code in a Blink directory. So how the new implementation looks like? As you can see in the table, each of the old implementation has a corresponding new implementation, and you can find more information down in the links attached. So this is a small example where we are using the type traits. Let's see some numbers. This graph shows the progress that we have made in the last 1 year. Till now, 181 patches are landed, 978 files are modified, and the pre-submit warnings are added against the use of deprecated downcast functions. So what is the progress? We are completed the 50% of migration till now, and big thanks to the reviewers. And what's next? We are planning to complete the remaining migration, and we are expecting this task to be completed before the BlinkOn 12. Thank you.
Thank you very much. So the next speaker is Igu.
Right. My name. Oops. How to. Awesome. Okay, thanks. Again, my name is E. I'm from the animations team. We got together here for the web, and what's fun on the web? Animations, right? And it was more fun on the web, rich animations. Okay, so let's begin. I'm going to show you how to write rich animations with a low cost in an ergonomic way. I don't know about you guys. I really like this animation. You know, this animation, they look attractive, because it's rich, and it feels organic because it's green. So how do we write animations like this? All right. So there are 153 dots. If you're interested, that means 153 animations, 1 per dot. All right, so you can write web animations manually according to those animations, and good luck. Or you can use like libraries, right? Because we love libraries, but still you need 153 animations, and the pen is not on your side, but the browser won't like it. All right, and more importantly, the rough-based animations they run on the main thread, and the main thread, it's just like Highway 101, right? So it could be busy, it could be very busy, and during rush hour, it doesn't matter how performant your library is, and it doesn't matter what kind of vehicle you're driving. You're driving Honda, you're driving Tesla, you're driving Lamborghini. It does not matter because you're going to be slow, right? And the animation will be looking bad. So what's the alternative here? GroupEffect, right? Yeah, that's my title. So GroupEffect is just a way to put a lot of effects into one animation, and you just play that animation. And it's very easy to write, easy to coordinate, easy to maintain. And more importantly, it's compositable, which means this animation can run off of the main thread. So it's like you're driving on the express lane and like, see you guys, it's very cool. And you get all of that with just 4 lines of code. Very simple. Okay, now you may. Thanks. All right, moments to confess. It's actually more than 4 lines of code. Sorry about that. In particular, we don't construct a group effect directly. There are lots of ways to for grouping bunch of effects. So we construct a group effect through its 3 concrete subclasses, like their parallel effects, all effects running in parallel. So sequence effects, they start one by one, and stagger effects, this one's fine. It's like they start together, but with different time delays. So it feels like staggered, and it's very popular on the web right now. And the demo I show you at the beginning is kind of a stagger effect. All right, status of this project. We have an explainer, so if you're interested, please check this details there. And we sent out a PR to the web animation level 2 specification. There are some discussions there among different browsers. In general, people are happy about this idea, but there is still some feedback we need to address. And meanwhile, last but definitely not least, we have a polyfill. So please try it out and build animation yourself. And any feedback is welcome. All right, thank you.
Thank you very much. The next speaker is Omer.
Okay, hi everyone, I'm Omer, I work on Oilpan. Yesterday, Anton was here to discuss Oilpan's sweeping phase, and today I'm gonna talk about the marking phase. So when Oilpan originally launched, we had atomic marking, which meant we stopped everything and did all of marking at the same time, and that was obviously very bad for Genk. So last year, we moved to incremental marking, which interleaves marking with the app itself. And we have these small steps that happen once in a while and make progress on marking until we finish it. Last week, I checked on UMA on the 99th percentile, and I saw that the incremental marking itself still takes about 75 milliseconds. And it might be fine for now, but as we move more objects over to Oilpan, it's only going to get worse. So to overcome it, we're moving on to, why is it jumping all the time? Yeah, so to overcome it, we're moving from incremental marking to concurrent marking, which means we're going to move most of the work over to concurrent threads, release the main thread, reduce the junk. And today I'm here to announce that this is coming soon to an open near you. Well, to be more precise, the first phase of it is coming soon. It's going to be mostly concurrent, but we're going to push a few more revisions in 2020 to make it fully concurrent. And so if the first phase will look something like that, eventually down the line, we should get to something like that, which has smaller interrupts on the main thread, smaller parallel final pause, we would support more threads, we would mark everything concurrently, and we will get off the main thread almost entirely. So to wrap it up, use Oilpan. Thank you.
Thank you very much. The next speaker is Sam.
All right, everybody. My name is Sam Goto. I am a software engineer on the Fugu team. Let's see if it works. All right. You may have seen this in different venues, but we wanted to report on an experience that we had on the Fugu team going through the Blink launch process. So you're familiar with this pipeline. If you got things into intent to ship or intent to experiment, you started at intent to prototype, and you go through this hacking phase, and then eventually at some point you enter origin trials. In the Fugu team, at some point we realized they were really bad at estimating entering to origin trials or intent to ship. We were just failing at predicting when that was going to happen, and we were asking why. We ran a postmortem to try to understand that a little bit better. But then we realized that it's not just us. Everybody else is too. So all of you, if we went through the BlinkDev mailing list and we looked at the time that it normally takes all of you to go from intent to prototype to intent to experiment, and it normally is on average 2 quarters with a variance of 2 quarters too. So it can take up to from 0 quarters all the way to almost 8 quarters. So massive variation in this. So predictability was in our best suit, but also isn't yours. And so when we debated a little bit about ourselves, we explored an alternative, which is to artificially introduce a stepping stone, a middle of the ground, where we call this where we have like a stepping stone that we can say to people like, we're gonna get here first, and then we're gonna get to origin trials. We called it Dev Trials internally because it seemed like an interesting name. And then we pulled that to ourselves. A lot of things that we will normally do later, we pulled that to do earlier, specifically with regards to engaging with partners. So it has certain different properties than origin trial does, and it does it complementary to origin trials, not to the exclusion of origin trials, but it has a different property. So it's released in canaries. It gets released every day. It has different goals, and it has different entrance criteria and different exit criteria, and then you test different things. When we started in 2019, this is a very scientific graph, so stay put with all the data points here. When we started in 2019, we had intent to prototype, intent to experiment, intent to ship. That was more or less where we're at. We almost had 1-to-1 between intent to prototype and intent to implement. But then we introduced this co-design phase, and with that we were able to kill some projects sooner before they got to intent to experiment. And so we were lowering our costs in terms of like getting stuff to intent to experiment that were too expensive to do, and decreasing our intent to extends. So with that, very scientifically again, with that resources, we were able to increase the number of intent to prototypes that we were sending out, while still decreasing the things that we were failing earlier. We're failing more often, but earlier too, without paying the cost afterwards. At some point, we believe that this is gonna converge, and it's not gonna magically create resources. But I subscribe to Kentaro's projection scientific method, and I think we're gonna at some point get to this.
Thank you very much. The next speaker is Gyuyoung.
Hello, I'm Gyuyoung from Italia. I'd like to share more people about the onion soup and the status simply again, although 2 main sessions already mentioned it. Okay, so onions started in November 2015. As you know, there are many old layers of extraction which didn't make sense and unnecessary in Blink. After the Blink was poked in from WebKits. So Blink needs to make it simpler as well as the empower developers to implement the features simpler, easier and faster. The goal of the onion soup is to make this. The goal of onion soup is to remove the abstraction that prevent interfacing with the rest of Chromium. So to achieve the goal, the project has planned to replace the legacy IPC with Mojo and move the feature from content generator to Blink and remove the public web API in Blink as much as possible. Helping you understanding about the onion soup, here is a simple example. This diagram shows how was call flow changed after onion soup on daytime chooser in Chromium Android. To do onion soup, I converted the legacy IPs to Mojo interface first. Then I removed the unnecessary functions in content layer, and then I moved the needed logic to Blink. And then, as you can see a simpler call flow in the daytime choosers in Chromie and Android. This is the conversion from legacy IPC to Mojo interface. As you can see, the Mojo interface is more readable and close to C++ style. Igalia has been working on the Onion Soup in earnest since February this year. We have deprecated the Blink public API and when it's unused or it's only used by Blink. And also we have been working on Onion Soup when it's used only by a couple of core sites in content. You can find the detailed progress in this link. By 13 August this year, the 93% have been done, replace legacy IPC with Mojo. 87% has been done to migrate the features, and remain item has been assigned to each team. So I think the initial vision of Onion Soup was done mostly. Yeah, the Onion Soup 2.0. 2.0 aim to massively simplify the interactions between the Chrome layer and Blink layer, as well as reduce the technical debt further. Hara can already mentioned in his main session. 2.0 have planned to finish Onion Soup 1.0 and switch Mojo to new syntax and convert the legacy IPC to Mojo in content more and slim down Blink public API, remove the export layer in Blink. And lastly, Igalia will keep working on Onion Soup 2.0. Thank you. That's it.
Thank you very much. The final speaker is Dave Tapuska.
So along with the topic of Onion Soup, it's not my slide, I was going to talk about Blink frame Mojo messages, but I'm going to talk in a story format. Everyone wants to meet Chromie. I'm not an visual artist, so this is Chromie. He wants to introduce, or they want to introduce a new feature to Blink. And they want to introduce a barrel roll. Everyone knows barrel roll on Google. You get to, it spins around. So there's a set of things that fit into Mojo well-defined interfaces, and then there's a set, all the frame messages that kind of don't fit, like focus and things like that. There's some like this. So Chromie goes along and tries to add the feature, and they end up with 29 lines chain or 29 insertions. This makes Chromie sad. Yeah. So Chromie takes another look. Chromie finds a frame.mojo interface inside Blink. Discovers that it contains a remote frame host, a local frame host. Those map to render frame proxy, render frame host impl, and on the Blink side, you have local frame and remote frame. Same change, 10 lines with testing code, 5 files changed. That makes Chromie happy. So less boilerplate, right? 1/3 of the original size. One whole set of virtual calls is removed. It's easier to test because the second change had test code in it. This is reducing Blink's API surface. It's moving it to Mojo. So that web remote frame and that web local frame actually will minimize down to not a whole lot of stuff. You'll talk to it via Mojo. Yeah, the end goal is to actually remove content renderer. This is part of the Onion Soup work, removing their legacy Chrome IPC. One last graph. This is the last. This is the number of Chrome legacy Chrome IPCs. This was before this was added. So some are moving. If you add new ones, please look at the new interfaces. All of them won't move yet because there's still some dependencies in content renderer, but that's where we're going. Thank you.
All right, thank you very much. So finished. So we are on time. Thank you very much. So we will have the final lightning talk session at the end of today. So see you later.